Hi transmission and distribution professionals. So now I'm going to teach you how to create a V Crossarm on a pole. So let's get started.
This is called V Crossarm on pole bracket post insulator. So as you can observe here, there's an insulator at the top, and then the crossarm shape looks like a V. So I'm going to show you how to create this in PLS POLE. First of all, what you need to do is create a new file. So I saved this file already. I do have a database of poles already here, so I'm going to use wood pole for I'm going to use this one. So for those of you who are asking, you can create a new pole here, and you can use a database of pole from PLS. They do have a database already. So just let me know in the comments below if you want me to teach you how to create a pole that corresponds with your specifications. So for now, I'm going to show to you. I do have a existing pole here. I'm going to use this, and then I'm going to go to the geometry and then wood poles. So this is the part where I'm going to insert the pole into the working space. So as you can see here, the three boxes still doesn't have poles yet, but after we input this, you will see. I will just name the pole PL. Then we don't use this yet, but if ever you do have the data, you can also input it here, the location. So for now, don't need that. So this is the pole what I have from the database here, my local file. So I'm just going to choose DF260. And for the material property set, so hardwood, or let's try Southern Pine A. So this is from the PLS database. Now, attachment labels, this is the location of the holes at the pole. So we're going to label that. So let's go back to the sample here. So how many holes in the pole will we need? So one. This doesn't have a bolt here, but this it does have two. So that will do it. So let's try. So one and then two. So you can name it any name that you want, alphanumeric. This is, you can enter a letter here, so it doesn't matter. So distance from origin, top joint. So let's try 0.3 meters. So what this means is that from the top, you're going to drill a hole 0.3 meters from the top of the pole. So this one. Let's try to estimate maybe 2 meters. So you don't need a hole diameter for now, and hole azimuth. So push brace, no base connect. We're gonna put this fixed. So, okay. So we do have a pole here already. As you can see here, the hole or the attachment points are labeled at the location. So let's try to do the top one first. This one, the middle post insulator and its support. So how are we going to do this? So first, I would introduce you to the concept of using Davit arm. So we have tubular steel Davit arm, and we have tubular steel cross arm. So these ones are the most convenient to attach to the pole because these components don't require too much data. So unlike the cross arm, Davit, so both of them require lots of data to be entered before it would accept, or it requires complete requirements of data. But here in the Davit arm and cross arm, it doesn't require too much of the data. So you can leave some blank and you can simulate already. So we're gonna. So another tip, if you're going attach something at the pole directly, you should use tubular steel cross arm. Why? Because I will explain later. So let's do this. So we have to create a new cross arm. So the prefix would be AB, and then top arm, and then steel shape. So I made this R because the shape is rectangular, the cross-sectional area. Thickness. In these areas, we're just gonna have to assume. So the thickness, we could use 10. For the diameter, make it 100. Then the length, 3.2, because as you can see, this is pretty short. This is the length, and the width is this. This is the width, this is the length, or the diameter. So, modulus of elasticity, just assume this is the common factor or common modulus, and then let's assume 1.6. For the geometry, since here at the cross arm, if you would need hole or a joint at the middle, that's the time you're gonna have to enter this. But for now, we don't need that because we need entered a length already, so I would show you later on. We don't need a geometry label here. And then calculated, and also assumed, and then also assumed for this, also assumed, and also assumed. So in short, what you're gonna need here at the tubular cross arm properties would be the label, the steel shape, the thickness, the diameter or depth, the length, the modulus of elasticity, the drag coefficient, strength, check type, basically all of the white cells. So this one, the texture for visual representation of the steel. So for now, this should do it. So we now have the database for the top bracket support. So we're gonna input that now here at the top of the pole, or instead here at PL1. Stand corrected here at PL1. I'm gonna insert that here. So we're going to geometry, tubular steel cross arms. So label this as T. So one tip, make sure that the cross arm connectivity label is different from the property label a while ago. So you would not have a hard time identifying those two. So cross arm property set, the one that we did is this AB top arm. So 0 for azimuth, So the slope would be 0. Attachment labels. So this one, also if you're gonna have to put a joint at the middle of the crossarm, you're also allowed to enter it here. But for now, we don't need that. Just have, so for the next column, connects. This one, we would enter, where would we put the top bracket support at the pole? So it asks that. So if you click that, there's a attach label, offset, connect at, connection code type. So the attached label, this is the origin and the end of the cross arm. So in short, these are the two ends. And then the offset, since a while ago we entered 0.2 for the length. So from 0 up to 0.2, it is labeled here, and then connect at. So we would connect this at the origin. So it means we would connect PL1. This is the attachment point from the pole or at the pole, and then we would attach it at the origin side, origin joint. And I would choose the connection code type pin face, so that it is connected at the surface of the side of the top of the pole. So as you can see here, obviously it looks like it is in the wrong configuration here, as you can see. So what should we do here is that rotate this tool. Let's try this one, slope. So there you have it. So now, after that, how are we going to create this? So where are the joints in this V Crossarm? One is 0, 0. And then this is the first joint. The second joint, not only for the connection point but the hole, we need to label that. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Hole. So 1. Just count it again. The hole for the attachment of the post insulator. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we would need 10 joint label attachment points. Have to create tubular steel cross arm. AVV arm. That would be the name. Then shape would be square. Then same as a while ago. So this is the real deal. Make a middle point. Name we can name this as AB and then middle. You just have to divide this by 2. So and just assume this is calculated, and then 0, and then galvanized steel. You have the properties, you just have to insert this. So let's go to geometry and then tubular steel cross arms. So stainless AB VX arm, or just VX arm because a while ago we had that prefix. And then AB V arm, sorry, V arm 0. Attachment label, you have already input this We have an input this. So now here, which one of the joints it should be connected to the pole? So here it should be this ABM attachment point. From the cross arm, you would attach it at the pole at hole 2 or joint 2. So what would be the connection code type? It should be pin face, so that it would be attached at the pin at the face of the pole, at the surface. So that's it. We have one. So we're gonna create Davit arms now. So just a little bit of info. So in the cross arm, we could not make an arm that has a slope. You could only make a Davit arm cross arm in a horizontal configuration like this. You could not make it have a slope like this. So we're gonna have to use Davit arm for this. So we should go to components, tubular steel Davit arm. Let's name this as AB Davit arm 1. So the shape would be the same, and then thickness 10, and then base diameter. This is all just estimates, as I've said a while ago. We don't have the data. 2.6, and now we're here. We should name the label first, and then the horizontal offset. Let's say the origin is at the left, and if you put 0.31 here for the horizontal offset, you would move 0.31 meters to the right. And then vertical offset, it's either up or down. So for up, we would make this negative. I will just explain that to you later on. And then assumed these two values are just assumed. 0 are for the shape, and galvanized steel for aesthetic purposes. So we have now the property, and now it's time to insert one. Let's try one at first. So tubular steel Davit arms. So let's see, right. RDA attachment label. We would attach this, so we have to check the attachment point here. So V arm E and V arm O, origin and end. So let's try the right first because we put letter R here. V arm E. Davit property set. The name of what we created. ABDA1. Azimuth is 0. Let's try to see what would it look like. So as you can see here, it seemed correct. Now I'm gonna explain what I did a while ago for the attachment points here. This just look like in opposite order, so let's just leave it like that. So this is what we have. So the 3 points are here: the Z, the PI, and the M. And next, we need to put this on the other side. So we will go to geometry, and then tubular steel Davit arms. So let's name this as LVA for left Davit arm. Same properties. I'm sorry, this would be the attachment label. So you should attach it at V arm origin, Then the same properties, AB Davit arm with 0 azimuth. So as you can see here, they have the same orientation. So how could we rotate this? We should make this 180 degrees. So there you have it. There's no covering here, but with the calculation it should be the same. Now, just that the distance between the two are from the left and right insulator, and the top insulator would be too high. So let's adjust this. So let's click on the pole, member info, and then pole. Let's reduce the attachment from 2 meters. Let's just make it 2.7. This for the distance from top origin. So yeah, that should do it. Now let's attach some post insulators here. So components, insulators, and then post properties. As you can see, we already have the sample here. If you have a data sheet, that would be great. So what are the things that you must enter? Those are the cells with white color. So for now, I would just use vertical PI label. Let's go to geometry, insulators, post insulators. Let's name this A, structure attach, each attachment point. First is for letter A, this one, LDAPI. Let's search for this. Tip label, let's name this A. Property set, vertical PI, azimuth 0. No brace, don't need that. And for the required vertical load, it must be no uplift. For the phase B, this would be the top bracket E. Then label it as B, and then vertical PI 0, no uplift as well. And then letter C, for this one, RDAPI. Then letter C, vertical PI, the same, and no uplift. So now, there you have it. Let's check. So what's left for us to do is the brace between post insulator A and post insulator C. So let's do this. So let's go to geometry, then braces. Let's name this as PRC. Then for the origin, we would have to put this to LDAZ, and for the end label, we would have to put this to RDAZ here. LDAZ and RDAZ. And let's name this as, for the property set, you could choose any of the available. So I would choose this one. And if you want to create a new property set, just click edit properties at the bottom right corner of the screen. And if you want to learn how to create a brace, so just let me know in the comments below. So just have to put this to standard and then press OK. So there you have it. You already have a brace, and this is complete for now. So if you have any feedback or comments, feel free to comment in the comment section below. And also, thank you so much for watching. If you want to learn more, please let me know. You can suggest any configuration and I will make a tutorial for you. Thank you so much. Bye.